If you guys ever wondered what it's like to run an IBC3 boom, well, I'm going to show you guys how to do a calibration on the boom. And you want to keep this video in case you do run one of these IBC3s on a John Deere. It's a big help. I'll show you exactly what you need to do and keep that boom running smooth and, you know, make your job a lot easier. So here it is.
So IBC needs to be off for this calibration. So it's going to tell us what position it wants to be in based on all the sensors. We're looking for OKs everywhere. Oops. We hold down the right toggle in zebra. It's trying to find the minimum current required. Now it's already beyond that. So that's it, it's done. Let that go. It's going to tell us our new values. So this line across the top is our new values and this is the previous, so no big changes here. No big changes here and only minor changes there. Down a little bit. Larger changes on main boom down rather than main boom up. So when it went through its first little cycle here, the first thing it does is tries to find the minimum current required to make movement or to start the movement for that particular function. Then it finds the midpoint. This is sort of predetermined in the background. And the maximum is your maximum velocity target. What milliamps does it require to find this target? And there in the background there's a parameter range for that. We'll go to the next cylinder. So we want to have OKs everywhere. So with the IBC cylinders, sensors inside the cylinders, they can tell us the angle of the boom, so they kind of make it easy for us. we got OKs everywhere, and it's going to allow us to start with the Z-bar. This one can be a bit of a trick because we don't have any dampening on our brakes.
Could get a little shaky.
Well, the brakes stop the head from swinging too much, so the head it won't hit the boom, or won't hit the machine, but it'll come close and it may won't let me. Give her a shot here. The junction box is the only thing that's trouble. Swinging too much. Right there. You can't control the timing as to when it comes in and when it goes out. It's an improvement that I believe they could make, but it's all built in the background. So that swing right there, I can't take it out if I wanted to. It's just waiting a predetermined amount of time and then it's going to come back in. So we're good. We got the first two swings are the most are the quickest, and the third and the fourth are just a little less. That's it. It was telling us the minimum, midpoint, and maximum values are now adjusted. Release the button. So I did. We're going to hit stop. Then gives us all the new numbers. Again, not a lot of change in the minimum side. Midpoint is pretty well predetermined. Different little bit different velocity there. The max velocity changed slightly. So we have the milliamps required and the velocity target. So there is a range. So the old target 166, the computer must have been satisfied with that. Now it's satisfied with 157. So this can all be changed at this point, but these are numbers spit out by the computer based on precise engineering. So next cylinder. Same thing again. It's going to get us in the tell us where it wants to be. Wants the extension out a bit. K's everywhere. There's Z-bar, Z-button. So this happens on each cylinder, in case you missed it on the first one. It always does the minimum, the midpoint, and then this screen pops up saying, hey, the boom's about to move at extreme speeds in both different directions, so just pay attention. So it's telling you to release the button and then hold it down again.
Swinging there.
Yep. Oh, gee. There's really nothing nothing I can do, because it's not built into the programming for me to have any influence on the timing. You just hold the button and let it go. That's so that's done. Some new values there. Minor adjustments, nothing too major. I'm really surprised actually that very little change in the minimums. That's has a lot to do with the way the machine feels, how functions start, and the fine tuning and the small adjustments. That column there. Next cylinder is the slew. So slew cylinders don't have a traditional IBC cylinder like we call it. They have a slew sensor, which is just a different type of position sensor. There is electronic dampening built into it also towards the end of stroke. When it's calibrated and it knows where the end of stroke is, it begins to slow the oil down as it gets there. But then there's also mechanical dampening in those accumulators. And they need to be there and alive and well. There we are. A little bit of changes, nothing too serious. So that's it for your IBC.